Hello friends, my name is Kinjal Bhavsar, lecturer in EC department from VPMP Polytechnic College. Subject name Microprocessor and Assembly Language Programming. Unit name 8085 Instructions and Timing. Then topic Instruction Size and Addressing Mode. These are the objectives. First, instruction size, then instruction format, then addressing mode. Type, that means second unit 8085 instruction and timing. So first of all, now start instruction size. So size of instruction is measured in bytes. According to that means the number of bytes that instruction occupy in memory. Then according to byte size of byte, instruction divided into three parts. First part, single byte instruction, second 2 byte instruction, and 3 byte instruction. First, single byte instruction. So single byte instruction specify both opcode and operand in same byte. That means it required only 1 byte storage in memory. Then example of single byte instruction is move B to A. That means copy the content of register B into register A. Then hex code of this instruction is 78H. That means this instruction is single byte instruction and it requires only 1 byte storage in memory. Another example of single byte instruction is move C to B. Another example is move C to B. Hex code of that instruction is 41H. Then LDAXB. Hex code of that instruction is 0AH. That means it requires only 1 machine cycle, otherwise it requires only 1 byte storage capacity. STXD, hex code of that instruction is 12H. It requires only 1 byte storage in memory. Second, 2 byte instruction. So in 2 byte instruction, first byte is opcode of instruction and second byte is operand. Then it requires 2 memory location in storage. The example of this instruction MVI A32H. So in this instruction, it's occupy 2 consecutive memory location. That means in first store the hex code of MVIA, that means 3E, and second code store 32H. That means it's occupy 2 consecutive memory location in memory. Like 2004 store 3E, that means hex code of MVIA, and at 2005 store 32, that means 8-bit data. Next, 3 byte instruction. So it specifies opcode with 16-bit address. Then in this, second byte contain lower order address and third byte contain higher order address. So example of that instruction LDA 2050. That means load content of memory location 2050 into A. Then this instruction require 3 memory location to storage. Like first store hex code of LDA instruction is 3A. Then second lower byte 50H and higher byte 20H. That means it requires 3 memory location to storage. Then another example of 3 byte instruction is STA 2050. So in this, first location store 32H. 32H is a hex code of STA instruction. Then 50H and 20H. That means stored content of accumulator into memory location 2050. Another example is LXI H2050. This instruction loads 16-bit data into HL pair. Then in this, first 21H. 21H is a hex code of LXI H. Then 50H and 20. Lower byte and higher byte. Next topic is instruction format. So first of all, in instruction, always this registers is used like B, C, D, E, H, L, and A. Then equivalent code for that registers is in B 000, C 001, then D 010, E 011, H 100, L 101 and A 111. Suppose we use register pair, the equivalent hex code of register pair BC is 01, DE is 01, HL pair is 10, then AF that means ki accumulator and flag, then SP that means ki stack pointer, then hex code of that is 11, that means ki 1. Then example of that instruction format, suppose move R2 R1, that means ki which transfer content of register R2 into R1. Then example of that instruction is move B to A, that means copies the content of register B into register A. Suppose for hex code, equivalent hex code, this is 8-bit data, that means D0, D1, D2, D3, D4, D5, D6 and D7. Then in that 8-bit data, D0, D1 and D2 is used for equivalent code for source register. Then D3, D4 and D5 is used for equivalent code for destination register. Then for move instruction, this 01 is fixed code. Then example like move B to A. So in this B register is source register and A register is destination register. Okay, so first 01 is fixed, then as a destination register, which register is used? A. Then equivalent code for A is 111. Then as a source register, B register is used. Then equivalent code for B register is 000. Then according to 8421, find out this. So this 842, according to 8421, this is a 7 and 8. That means the equivalent hex code of move B to A is 78H. Then next for A to C, then 01 is fixed, equivalent code of C is 001, then equivalent code of A is 111, then according to 8421, 4FH. Then next B to D. So in this 01 is fixed, equivalent hex code of D is 010, then B is 000, then according to 8421, 50H. Okay. So and then this for this instruction move A to B, again 01 equivalent hex code, then B 000 and A is 111, that means ki 47H. Now start second example. MVI are 8-bit data. So this instruction copies 8-bit data into register R. Okay. Then example of this instruction MVI A55H. This instruction copies 55H into register A. Then for equivalent hex code, this format 8-bit data D0, D1, D2, D3, D4, D5, D6 and D7. Then this D0, D1, D2, this 3-bit is fixed 110. Then D3, D4 and D5 is used for destination register, and D7 and D6 bit is for fixed 00 for MVI instruction. Then this example MVI A55H. So first 00 is fixed, then as a destination register accumulator is used, then equivalent code of accumulator is 111. Okay, then 110, that means ki according to 8421 equivalent code is 3E, that means ki this 3E is equivalent hex code of MVI A. But this instruction is 2-byte instruction, that means ki next location is 55H. Then second example MVI B 65H. So in this D7 and D00 fixed, then B destination register as a B register. So B equivalent code of B is 000. Then 110 is fixed. Then according to 842106. Then MVIC 95H, for that this 00 is fixed as a destination. C register 001. Then 110 is fixed. Then equivalent code of that instruction is 0EH. Then next instruction is LDA address. So 8-bit data D0 LDA address. So 8-bit data D0 to D7, and for that instruction this format is fixed. Okay, 00111010, and equivalent hex code, that means ki according to 8421 equivalent is 3A. That means ki equivalent hex code of LDA is 3A. Then store 50H, that means ki lower address, and 20H, that means ki high. Next topic is addressing mode. So addressing mode provide flexibility to instruction. Then mainly 5 different addressing mode, like first implied addressing mode, then register addressing mode, immediate addressing mode, direct addressing mode, and indirect addressing mode. First, implied addressing mode. In this, implied instructions does not use any register or memory location. Okay, that means ki in this addressing mode, instruction does not contain any register or memory location. The example of that instruction is STC, that means ki set carry flag, CMC, that means ki complement carry flag, then HLT, that means ki end of program. Second addressing mode is register addressing mode. So in this addressing mode, it specifies its operands using only register. Example of that addressing mode is move B to A. Okay, that means ki in move B to A, before execution of this instruction, content of accumulator is unknown. Then content of B register is 6C. Okay, after execution of this instruction, content of B is transferred to A. That means ki content of register B is transferred to A. That means ki accumulator. That after execution of this instruction, content of B register and A register is same. Next addressing mode is immediate addressing mode. So in this, store data immediately after opcode. So example of that instruction is MVI A32H LXIH2050H. This instruction, this MVI A32H store 8-bit data 32H immediately into accumulator. So in MVI A32H, this is a 2-byte instruction. That's why here require 2 memory location for storage. Before execution of this instruction, content of accumulator is unknown. Okay, then after execution of this instruction, content of accumulator is 32H. That means ki immediately 32H is transferred to accumulator. That's why this mode is immediate addressing mode. Then next example is direct addressing mode. So in this, address of operand is directly given within instruction. That means the address is directly given within instruction. Then example of this instruction is LDA 2050, otherwise STA 2050. So first LDA 2050, before execution of this instruction, content of accumulator is unknown. Then content of 2050 is 55H. That means after execution of this instruction, content of accumulator is 55. That means ki content of 2050 is transferred to accumulator. Second example is STA 2050. So STA 2050 store content of accumulator to 2050 address. That means before execution of this instruction, content of accumulator is 01010. That means ki 55H. Then after execution of this instruction, content of 2050 is 55H. And content of accumulator is same as. Next, indirect addressing mode. So in this use indirect addressing specify the address of operand indirectly into register. Like example of that instruction is move M to A, otherwise move A to M. So move M to A, this instruction copies content of memory location specified by HL register pair into accumulator. Okay, so explanation about this instruction. Move M to A. Okay, before execution of this instruction, content of accumulator is unknown. Then data memory, that means ki 3050 is 55. That means ki memory, as a memory use address 3050 and content of 3050 is 55H. That means after execution of this instruction, content of accumulator is 55H. Then this instruction, okay, here LDA 3050, okay, is equivalent instruction of these two instructions like LXI S3050 and move M to A. That means ki before execution of this instruction, memory address is specified in HL pair. Next, HTA 3050, in this before execution of this move A to M, LXI A 3050, that means ki 3050 address is specified before this instruction. Thank you.